All right, make sure you have out paper. You can bring up Schoology if you want to follow along with the notes that are already posted there for you. Have you guys did y'all have a good day yesterday?
Yeah.
Is that right? I know I'm ready for fall break, so I'm sure you guys are too. All right, today we're going to look at rational functions. In the last lesson, we talked about polynomial functions in 2.3. And remember that polynomial functions were smooth and continuous, could not have any breaks at all, could not have any holes in their graph. Well, today we're going to look at graphs that do have branches, do have breaks, they have asymptotes. Do y'all remember what asymptotes are from last year? It's like kind of like almost an invisible line on your graph that it approaches but never touches. Well, except for horizontal asymptote. Remember, there's always one thing in math that always breaks the rules and goes against what you've learned so far, but we'll talk about that later. But a rational function is simply a function that's made up of two polynomials, and of course it looks like a fraction. It may simplify to where it's not a fraction, but to start off with, it will always look like a fraction and have a polynomial on top and a polynomial on bottom. So what we're going to look at as far as graphing these, we're going to talk about how you find the domain of a rational function. Domain of polynomials was all real numbers, because think about it, those graphs were smooth, continuous, and they continued on forever to the left, to the right. And so your domain was all real numbers. But domain of a rational function, we have to figure out where it's undefined. Where do you have an asymptote at? Where do you have a hole in your graph? And what you look at, of course, is your denominator, because you know in a fraction, the denominator can never be 0. So we're going to look at how you find domain. We're going to look at how you find the vertical asymptotes that your graph might have, how you find the horizontal asymptote that your graph may have. It will have at most one horizontal. Then we're going to talk about how you find a slant asymptote. That's brand new to you. Hopefully you remember a little bit with vertical and horizontal, but when you get to slant, you're going to love the process that you have to use to find that. It's involved. Then we're going to graph, look at symmetry, see if it's symmetric with the y-axis and origin. You did that 1.3 when we talked about even and odd functions. Are you overwhelmed yet? All right, and then I'm not going to make you graph these by hand on paper, and you'll be thankful for that, because the graphs are like, this is one of your basic graphs. That's what they look like. So then you start graphing decimals, fractions. We're going to graph them in decimals. I'll let you type them in, double check your graphs that way, which some of you may already have been with the previous lesson. Okay, so let's first talk about how you find domain. It's, of course, the set of all real numbers except the x values that make the denominator 0. So we exclude any values of x that make denominator 0. And we're going to write it, I think in MATLAB, they write it in set builder. I'll show you what that looks like. But for example, in this case, you've got x squared minus 25 over x minus 5. How would the numerator factor? How could you factor the top? What'd you say? Difference of squares. I knew where you were going. Difference of squares. So it would factor into x plus 5, x minus 5. That x minus 5 on the bottom would cancel off. But even though it cancels off, 5 is the only value that we exclude, because that would make the denominator 0. Do you guys remember? I'm getting ahead of myself, but when you set the denominator equal to 0, that's either a vertical asymptote or a hole. Do y'all remember what makes it a hole? Like 5 is either going to be a vertical asymptote or a hole in your graph. Did it cancel off with a factor on top? It did, so it's a hole. So anyway, we'll get there later. And of course, over here to the right, I put this one in your notes because people tend to forget, if you just see an x, that's also a factor. So x can't be 0 here, x can't be 2, x can't be -5. And then you write it in order. So -5, of course, would come first. So -5, -5, union, -5, then 0 comes next. Union 0, then 2. So make sure, whatever values you exclude, when you write your domain, you write them in order from least to greatest. So I'm just telling you again here, set your denominator equal to 0 to solve for the values to be excluded. All right, let's practice how you find domain. That's going to be the first thing you do in MATLAB as well. And I'm just going to take some examples from those that are already in your notes and work them with you. All right, this is number 2 from your notes. You've got function g of x equals x over x squared minus 25. Tell me how would the denominator factor? Into x plus 5, x minus 5. So what's your two values you are excluding? X can't be -5 from that factor, and x can't be 5 here. All right, this is what I wanted to show you that MATLAB puts it in. So I didn't want you to be thrown off. They say, like swirly race, all x such that x can't be, and then they give you a box here to type them in. So you'd say -5, 5. They give you something like that. But if we're putting it in interval notation, you would say domain is from what? -infinity to -5 first, good. And then parenthesis union, then pick back up right after -5. You go to 5, parenthesis union, 5 to infinity. Okay, this is number 4. I have function j of x equals 15x cubed over 3x squared plus 1. If I'm ever going too fast, you just tell me and I'll slow down. Are y'all good? Okay. All right, we need to figure out what values would make this denominator 0. Is there any restriction placed on x? There's not. Good. Because what are you doing with x when you plug it in? When you plug in any value, you are squaring it, so that will give you a positive number, and then you multiplying it times +3 and adding. So this is never going to equal 0. And another way you can double check that is just to set it equal to 0. I want to show you what happens. So if I do set that equal to 0, I get 3x squared equals -1, and divide by 3, so you get -1/3. Can you take the square root of a negative value? No. So like this, when you set equal to 0, it comes out to actually be an imaginary root. So in that case, you would say it's all real numbers. Like only an imaginary number would actually make this be 0. And so, but we're working in the real number system. So all real numbers. Okay, last one we'll look at, and then we'll move on to something else. All right, we got x plus 6 over x squared minus 2x minus 24. No, plus, change that to plus. This is just an extra example. This is not in your notes. Okay, how would the denominator factor in this case? Factoring is like in every lesson in pre-calc. X plus 6, x minus 4. Good. And so the two values you're excluding, x cannot be what and what? -6, nor can it be 4. So we won't finish that one, but I just wanted to go over one like that where you have to factor it as a trinomial. All right, before we look at asymptotes, I want to show you what two of your basic parent rational function graphs look like. And then we're going to talk about limits, and then we'll move on to asymptotes. Okay, so the first one that we're going to look at is the 1 over x. You graphed these last year in Algebra 2 trig. I don't know if you remember a lot about them, but to get your basic parent graph, I just chose to plug in like -2, -1, -1/2, +1, 1/2, and 2. And you get points, of course, at -1, -1, 1, 1, and so on to form those two distinct branches of your graph. Notice that, tell me what x cannot be from that equation. X can't be 0, so that's why you have a vertical asymptote at x equals 0, or otherwise known as the y-axis. And you also have a horizontal asymptote at the x-axis, or y equals 0. What part of your math lab assignment is going to ask you to do is just to take this parent graph and to graph it with transformations. So all you're going to do in those is you're simply going to take this graph and you're either going to slide it up and down or left and right. That's all you're going to do. So it will make, of course, the vertical asymptote you have and the horizontal asymptote change to something else, but you're going to easily see that. And I think most of those are even multiple choice in your assignment. But we'll talk about what you look at in your equation to help you know whether you're moving it up, down, left, right. Okay, let's look at the other one. This is when the x on the bottom is squared. So notice the difference. This one would be considered an even function because it's symmetric with the what? Good. It's symmetric with the y-axis. Let me go back up really quick. This is symmetric with the what? That's symmetric with the origin when it's in diagonal quadrants like that. Or your signs, I mean, notice that your ordered pairs rather completely switch signs, like -1 becomes 1 and 1. So anyway, that's another clue of origin symmetry. But this is symmetric with the y-axis, an even function. And the reason is, of course, when you plug in all these values of x and square them, you're getting positive values. So your y's will always be positive. And when you plug in -2 and square it, you're going to get +4, so that'll give you 1/4 for your y. And when I plug in -1/2 on the bottom and square it, I actually get a +1/4. But when you flip it, that's how you're getting 4. Flip it, multiply it to 1. So once again, they're going to ask you graph this with transformations. You're going to see a number added or subtracted with x and a number added or subtracted at the end. And you're just going to move this graph left, right, up, down. Okay, this is not particularly in your notes. Let's say I've got g of x, and they tell me to graph using transformations. We've got 1 over x plus 2, and then I have a -5 at the end. Graph using transformations, g of x, 1 over x plus 2, -5. All you need to remember is that a number added or subtracted specifically with x moves your graph which 2 ways? It's going to move it left or right, and it's opposite of what you think. When it's with x, it's opposite of what you think. So this is going to move your graph actually left 2 places, and it's going to be, tell me which one it's going to transform. Is it the 1 over x graph or the 1 over x squared? Be careful. Is x squared here? Right. So just that's all you gotta look for. If x is squared, or if x is in, if this was inside parentheses then squared, it would be the 1 over x squared graph. And so you would just take that graph that's going shooting up the y-axis and move it like left, right.
Lunch count on Google Doc at this time. Thank you.
Okay, so it's gonna move it left 2 places, and this tells you you're gonna move it which way? Down 5. The number at the end actually moves it up or down. So down 5. The number specifically with x is moving it left or right and opposite of what you think. So you would just take, it would be this graph that I'm moving, I'm shifting this graph left 2 places, down 5. All right, and let's say I've got f of x equals 1 over x minus 3 squared plus 2. So in this case, it would be the x squared graph, and you're moving it, tell me which 2 ways? Good, you're gonna move it up 2 places, and you're gonna move it right 3. Yes, yes. Are y'all okay with transformations? And you could, of course, type these graphs in You can type them in, but all you have to do is look back at your notes and think, okay, well, if I take that one and move it here, 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 which one is it? That's all you gotta do. Or type that in Desmos, which I'm gonna show you how to do later. Okay. Fun times in this next part. All right, if you are looking at your notes, you can look at the bottom or halfway down page 2. How many of you plan on taking calculus? Some point in time, maybe in college, here? Okay, probably. All right, you don't know? The first part of what you study in calculus involves limits. And calculus is the study of the average rate of change. So you're going to be looking at a lot of graphs in calculus and a lot of calculating area under a curve, things of that nature. So that's why they start off with limits, to use that in further study later on. You have limits to convey ideas about a function's end behavior or possible asymptotic behavior. So your graph, notice the two that we just looked at, they were basic graphs. Remember the even function shot way up, like as the graph was approaching the y-axis from the left side, your y was going to what? Like as my graph approached from this side, what are your y values going to? Infinity. And same thing on this side, like it was shooting way up, and so y was going to infinity from the left and the right. So that's what we're about to do, is look at what is the behavior of your y value, or f of x, as x is approaching infinity or certain values on your graph. And so this is what they use. They use what's called arrow notation. And all this means is that x, this is the way you read it, x is approaching some value a from the right side. So the little plus and minus up in the exponent area is just telling you, are you looking at your graph on the right side or left side? So x is approaching a from the left, x approaching a from the right. I mean, left. I got them backwards. Sorry, don't mean to confuse you. All right, and then this would just be as x approaches infinity and x approaches negative infinity. It's really not, there's really not a lot of work to it other than just examining graph, but it's just getting used to it at first in the notation of it. So let's look at this graph that I have on page 3 in your notes. And I'm trying to give you a good representation of things you will see. I put some of these on your review and your test, and 2.6. We've got this graph in blue, and of course you've got asymptotes at the x-axis, or y equals 0, and an asymptote at x equals 1 and x equals -3. So in number 7, they want you to find what the graph is doing. So they say as x approaches -3 from the left side. So this is -3, but I'm looking at, what does this graph do? What are my y's doing as I approach -3 from the left side? So I'm approaching -3 from the left. What is y doing? What's y going to do all the way down closer and closer to that value of x -3? Y is going to approach negative infinity. Do y'all see that? Okay. Tell me if you're lost or if it doesn't make sense. Or either maybe you're just so quiet you're bored to death. Tell me that too. Okay. Number 8, as x approaches -3 from the right side, what is y approaching, or f of x? So they're looking, as you're approaching -3 from the right side, notice that your y is approaching positive infinity, and it's going to keep going up, 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 up as it gets closer to that asymptote. So positive infinity for that answer. All right, let me shoot down the number. Are y'all okay with that? Yes or no? It's okay. Yeah, it's just different. It's weird. Number 11, as x is approaching negative infinity, number 11, as x approaches negative infinity, what is y approaching? So you have to look at your graph in relation to the y-axis. So as my x gets smaller and smaller and smaller, what is this y value coming closer and closer to in relation to the y-axis? What'd y'all say? 0. Good. So as x is approaching negative infinity, the y is getting really close to the x-axis, or y equals 0. And same thing as x is approaching positive infinity. So as you'll notice, x is approaching positive infinity, and then your graph is approaching y value of 0. All right. Are you guys ready to find some vertical asymptotes? All right, let's do it. Probably not, but I at least appreciate you saying sure. Now let's look at how you find your vertical, horizontal, and slant asymptotes, and then we're going to talk about symmetry, we're going to talk about limits, and we're going to graph one, and we'll be done. All right, for the vertical asymptotes, we've kind of already talked about it because that comes from setting your denominator equal to 0. You don't have to write all this other stuff if you don't want to. It's in your notes for you. But the main thing you need to, if you're writing this down, set denominator equal to 0. If a factor cancels, then that graph has a hole at that spot. So if it cancels off, it's a hole and not a vertical asymptote. Cancels off, it's a hole. Cancels off, it's a hole. And then we're about to work this part at the bottom. Did you get your coffee free today? It was supposed to be free coffee at Dunkin' today for like National something day.
Coffee?
Yeah, at Dunkin' today. Supposed to. Yeah. That's always a good thing too. I didn't pay for it. Okay, let's look at. Find the vertical asymptotes if there are any. This is number 14 in your notes. You have g of x equals -2 all over x squared minus x minus 2. You factor and set the denominator equal to 0. Well, I should have said factoring, but I think you guys know that by now. How will this denominator factor? X plus 1, x minus 2. Okay, the top definitely will not factor. All you have is -2. So both of these will be vertical asymptotes. So you'll have a vertical asymptote at x equals what and x equals what? At -1, good, and +2. Remember to change the sign because you're essentially setting this equal to 0 or saying what will make that 0, what will make this 0. I have a lot of people miss these problems because they'll put x equals 1, x equals -2. Don't do that. Okay, this is 15. You have f of x equals x squared minus 4x plus 3 on top. And on bottom, x plus 1 squared. So in this case, the bottom's already factored. We have to factor the numerator. Are you guys good with factoring rules? Are y'all okay with factoring? I figure by now you've been pushed through algebra 2 trig. You probably are. Okay, how will this numerator factor? Good, -3, -1. And so neither, I meant to make that, okay, I'll tell you what, switch. Change the sign. Well, never mind. Yeah, go ahead, change it. Okay, if you run into this, notice that only one of your factors will cancel. So you may have a vertical asymptote at x = 1 or a whole, since it's the same factor. But you have to graph it to check. So x = 1 or a whole at x = 1 there. Okay, how do y'all feel about finding vertical asymptotes? Are y'all good? Factors set equal. If it cancels, it's a whole. All right, let's move on to horizontal. They progress in work and what you have to do to get them. Horizontal and then slant. Save the best for last. Well, I'll show you here. You don't have to write all of this down, okay? I'm gonna tell you what you need to write down from these notes. I've already said a rational function can have at most one horizontal asymptote. And we already talked about how the graph can never intersect the vertical asymptote, but it may cross over. If a graph crosses over, and you don't have to write this down, unless you just want to. If a graph crosses over a horizontal asymptote, let's say I've got a horizontal asymptote here, and you may have a graph that does this, but then slightly crosses over and then picks back up. So even if it does cross over, it's just going to be very tiny. Okay, this is what you need to write down for horizontal asymptotes. What you're going to do is you're going to check your degree of the numerator, which I'm going to let be n. Degree of numerator, let be n. The degree of the denominator, I'm going to let be m. So what they're saying is that if your degree on top, or your highest exponent, is less than your degree on the bottom, then y = 0 is your horizontal asymptote, or the x-axis. So that's when my exponent on top is smaller than my exponent on bottom. Okay, when your degrees are equal, when n = m, the exponent on top and bottom are equal, the line y = x to n over x to m is the horizontal asymptote. And all that means is that I take my leading term on top and put it over leading term on bottom, and I simplify it. And you'll see what that, like we might have 4x squared over 2x squared becomes 2. So all you do is you take your leading term over leading term and simplify it, or really the leading coefficient, because you're going to have x cubed over x cubed, which is all going to go away, or x squared over x squared. So when the degrees are the same, you have a horizontal asymptote at leading term divided by leading term. When your degree on top is greater than a degree on bottom, your graph has no horizontal asymptote. So when your exponent on top is larger than the exponent on bottom, no horizontal asymptote. All right, is everybody good? All right, I want to go through some that I've already worked in your examples. All right, let's look at 18. So if you want to, you can write down number 18, or if you're following along, that's the one. Okay, so find the horizontal asymptote if there are any. So what you're going to do is compare your exponent on top, which is 1, to the exponent on bottom. Since my exponent on top is less than my exponent on bottom, then y equals 0 is my horizontal asymptote. So the degree of the denominator is larger, y equals 0 is your horizontal asymptote. All right, let's look at 19. 19, this is a case where you have to set the leading term on top over leading term on bottom. Your degrees are equal. So I take 4x squared, set it over 2x squared, but you can see what I was talking about when you really don't even have to take the x squared because it's going to cancel every time. So you take 4 over 2. So y equals 2 would be your only horizontal asymptote. So you'd have a horizontal line through y-axis at 2. Your graph would approach it, may slightly cross it. Just have to graph it and see. Okay, let's look at last one for horizontal. I want to show you one. Wait, hang on. Let's stop back up. Number 20. Notice that your degree on top is bigger than the degree on bottom. So in that case, no horizontal asymptote. That's what it looks like. Your graph will have a slant asymptote. Your graph will have a slant asymptote if your degree of your numerator is exactly 1 more than degree of your denominator. So if your degree on top is exactly 1 more than the degree on the bottom, you will have a slant asymptote and you have to find it. And what a slant asymptote looks like, and you don't have to draw this, but if I have a graph that looks like this, and you might have an asymptote that, of course, is slanted, and your graph can never touch that line. With slant asymptotes, they are never going to cross. But let's look at how you find them. You use synthetic division to find them. Do you guys remember how to synthetically divide? So that's good. It's going to be a good review for you on synthetic division. So use synthetic division to find them. And this is what you're looking for. So of course, you remember when you synthetically divide, you have a number. Do you have numbers, of course, all across the top? And then, do y'all remember what this number is that's left in this box is called at the end? This is always your remainder. Do y'all remember that? All right, this is how you get your equation. Whatever number is here and here, you don't care what the remainder is. So you really don't even have to do this last column if you don't want to. I am going to get y equals mx plus b. So my slant asymptote will always be in y equals mx plus b form. So in a minute, when we synthetically divide, the number you have here will be your slope. The number you get here will be your y-intercept. You don't care what this last stuff is. So I told you, it just progresses as we talk about vertical, horizontal, now slant. I don't know what number this is. I'm just going to say example. Find the slant asymptote. And you've got f of x equals x squared plus x minus 6 on top, all over x minus 3. Okay, so the first thing you check is your degree of numerator one more than degree of denominator. And yes, it is. So that's the case. So degree of numerator is one more than the degree of denominator. Now, what you do is you do the opposite. Remember, of course, this is your divisor. If I was actually dividing this, I would say that divided by x minus 3. So divisor, this is your dividend. So you always do the opposite of this number on bottom that's with x. So this will be positive 3. Then I'll write down all of the coefficients from the top or the numerator. What are all my numbers that I write? Okay, 1, 1, and you have to write that constant also. And then, of course, you leave some working room. Space your numbers out, too. Okay. Remember, you have to do what with this first number? You bring it down. And then what do you do with all the numbers that end up on the bottom? They get what? Good. They get multiplied by 3. And then I write that answer here. So 3 times 1. Yeah, I was going to say, maybe it'll come back to you a little bit. It's something, though, that you only visit like once a year. So it's kind of hard to remember. Anyway, put that answer here, and then you add down the column. So this will become 4. And then I multiply that to 3. So what number goes here? 12. And then, like I said, we really don't even care. Like, I already have my equation. I don't even care what that is, but if you want to do it, it's 6. So your equation, what is your slope? What number goes in place of m? 1. And then 4 is your y-intercept. So this is the equation of your slant asymptote. y equals x plus 4. So kind of a lot of work just to get an asymptote. Hey, Jason. Okay, if you were graphing this on Desmos, if you were to graph the line y equals x plus 4, you would have, of course, your y-intercept at positive 4, and then your slope is 1. So that line would be going through here. So you can see how that graph is curving, and then all of a sudden here it does a very sharp curve and almost straightens out in that direction. Y equals x plus 4. All right. How do you guys feel about slant asymptote? Are y'all okay with that? It's not terrible. It's just wait till you get to the problems in MATLAB that say use these 7-step process to graph this. And then they ask you to find vertical asymptotes, horizontal, slant, ask you to find y-intercept, x-intercept. Yeah, fun times. But I'm about to go through one with you and then we'll call it a day because it's already been, it's been long today. And then we'll talk about symmetry as well. All right, so when you get into the 7-step process, that's what we'll look at. Okay, let's graph this one, and this will be the last problem that we do. You've got f of x equals x squared minus x plus 1 over x minus 1. And they say graph using the 7-step process. So if it takes you 7 steps just to get everything, aren't you glad I'm not making you graph these by hand? Which you're at home anyway, so I really can. Or most of you are at home. All right, graph using that. I'm going to go through all the things with you. Okay, step 1 that they're going to ask you for, more than likely. I don't know what order particularly, but in your book, this is how it goes. They're going to ask you for symmetry. Does the graph show any symmetry, y-axis origin, or none? And this is how you check. I don't know if you guys remember this from section 1.3, but I plug in negative x. If you get your original, and you can, some of you can do this mentally. You can look at your equation and think, if I plug in negative x, are my signs going to change? Or are they going to stay the same? So if I get my original function back out, then it has y-axis symmetry. That's an even function. If I get the completely opposite function back out, if all of my signs change, guys, I mean, you can already tell, look, if I plug in negative x and square it, that will stay x squared. But if I plug in negative x here, what happens? Does this stay positive or does it change signs? It changes, right? So it's going to stay here and change here, negative x, that would make it become plus x. So I already know it's not going to have symmetry. But anyway, if you get the complete opposite signs back out, it's origin, and that's known as an odd function. But I can show you if you want me to. So negative x squared minus negative x plus 1. I can already see on the top that x squared is going to stay x squared. This becomes plus x and then plus 1. So some of my signs changed, some of them didn't. So it has no symmetry. Does that make sense? Are y'all okay with that? Do you want me to enlarge it? Sorry. Is that better? Okay. So only some of my signs change, so no symmetry. Okay, step 2. They ask you to find the y-intercept. So of course, you're just going to plug in 0 for x. So 0 squared minus 0 plus 1, and then 0 minus 1 on the bottom. Tell me what you're left with. What are you left with on the top? You're left with 1 over -1, which is -1. So 0, -1 is your y-intercept. Okay, step 3. They ask you to find the x-intercepts that the graph may have. There's a trick to this. All you need to do is set your numerator equal to 0 and solve. Because think about it, if I set y equal to 0 and say 0 times the denominator in any of these problems, that's going to go away. So set numerator equal to 0. Don't know why I just wrote down that bottom thing. All right, when I set that equal to 0, if it will factor, which this will, no, it will not, will it? Nope, it won't. That's awesome. If it doesn't factor, what do you have to use? Quadratic formula. God. Yeah. God, this one's going to be long. We have to use quadratic formula already on step 3, and it's 7 steps. Woo! Okay, so plug in, you get this becomes +1 plus or minus square roots. 1 minus 4a is 1, c is 1, all over 2. Okay, look, you get a negative underneath the radical. So are there any x-intercepts? There's no x-intercepts. Once I start getting imaginary roots and answers, done. No x-intercepts. Okay, step 4. Finally, to the vertical asymptotes. Vertical asymptotes. Good. This is really easy. Our denominator is x minus 1. So, and we know the top already didn't factor. So there is a vertical asymptote at x equals 1. Does that make sense? Everybody good with that? Five, horizontal asymptotes. So this is where you have to examine your degree. The degree on top is bigger than the degree on bottom. So is there any horizontal asymptotes? None. 6 is your slant. And the degree on top is 1 more than the bottom, so there is a slant asymptote. So I have to divide. If you look back at your problem, you do the opposite of the number with x on bottom, which will be +1. All of my coefficients on top are 1, -1, +1. You bring down that first number, multiply it. So what is your slant asymptote equation? This would be your what? Slope. So you got a slope of 1, and then my y-intercept is 0. So y equals x is your slant asymptote. Okay, step 7 is to graph it. Okay, so when you graph it in Desmos, we said that there should be a slant asymptote at y equals negative x. It didn't have any horizontal asymptotes, but it has a vertical asymptote if we zoom out at x equals 1. Okay, all right, how do y'all feel about 216? Okay, again, all right. Use the remaining time to work. You got about 30 minutes. You also have, so all we're doing this week is 2.6, and then we're going to spend the next classes working on your unit 2 review. That's got about 20, 23 problems on it, and then you've got a unit 3 review. Then you have a unit 3 test due Sunday night as well. Test shouldn't be that bad. Like I made it yesterday, and it's not too bad. You got 2 attempts on it, like the other ones.